Hello. Today on day 4, we are going to talk about functions. And what we're going to do is we're going to learn about what function notation is, how to read the function properly, how to evaluate functions, find a certain value in a function, and write an equation from words and solve. So let's start off. First of all, function notation is, getting a pen here. It's just a way of naming an equation. Okay, so a function and an equation are kind of the same thing. It's just that a function is going to be using something like f of x. It doesn't have to be f, doesn't have to be x. It could be g of x, it could be t of n. It just depends on what letters they chose to use. Now when you use function notation, we can identify the independent variable. The independent variable is the variable being used in the function. That's what's in the parentheses after that letter f. Okay, the f is the name of the function, and the name of the function is just any letter. So this guy right here would be the name of the function. The value that's inside the parentheses is the independent variable. So on the left-hand side of this equal sign, we're looking at the name and the independent variable. On the right-hand side of the function is the algebraic expression right here. Okay, let's take a look at the next page. What we want to do here is we want to be able to read a function, name it, and identify the independent variable. First of all, in number 1, I would read number 1 as g of m equals m divided by 5. That's how you read number 1. Now if I want to identify the name is just the g. Only the g, it's only the letter out front. The independent variable is what's in the parentheses, and that's just telling us what variable is being used in the algebraic expression on the right-hand side of the equal sign. So in number 2, I guess we can't see that. Number 2 says h of k equals -14 plus, and that's supposed to be 3 divided by k. That's how you would read number 2. If I want to name it, the name is just the letter in front. The independent variable is what's in the parentheses, and that would be k. Alright, now with function notation, the independent variable, oops, not a pen. The independent variable right here, this r, is what's located inside the algebraic expression right there. And if we want to do something called evaluating, if our directions say evaluate, we take the number inside the parentheses and then we plug it in for the x on the right hand side and do all the math on the right hand side. When we evaluate it, it's supposed to say side, but it's not coming out as side there. We evaluate it, we should come up with just a number. Okay, let's go on to how we're going to be looking at evaluating these functions here. Okay, to evaluate functions, we want to follow the order of operations. Order of operations, one way to help us remember the order of operations is something called PEMDAS. PEMDAS is the order of operation. All it is a mnemonic device to help us remember the order of which we need to perform the math. Parentheses, stuff in parentheses has to go first, then exponents, then multiplication and division from left to right, and then addition and subtraction from left to right. So suppose I have these two functions right here, f of x function and I have a g of x function. In number 3, it says evaluate f of 5. So to evaluate f of 5, that means all I do is take this 5 and plug it in for the x. And then everything should be all numbers. And then perform my PEMDAS, my order of operations here. Well, I have parentheses. 5 minus 2 is 3, so that has to go first. Then I have exponents, so I have negative 3. 3 squared, that means 3 times 3. I mean, I have 9 there, plus 4. Then I'm going to do my multiplication. Negative 3 times 9 is negative 27. Add 4. And then finally do that addition, and negative 27 plus 4 is a negative 23. So I evaluated the f function when x was equal to 5. Let's take a look at number 4. On number 4, we want to evaluate the g function, so I'm using this g function here. So I have g of negative 12. Since negative 12 is in the parentheses, it is replacing the x value wherever the x is. So on the right-hand side, I have 5 plus negative 12 divided by 4 squared. Now, order of operations says parentheses. Okay, so I have, this is my 5, plus negative 12 divided by 4, that's going to have to go first, so I have negative 3 squared. Now I need to do exponents, so I still have that 5 plus there. Now negative 3 squared means negative 3 times negative 3, which is a positive 9, and add that up, and I have 14. What I'd like to do now is take a look at some functions, but now the directions on these are a little different. Now these say find x, find p. These do not say evaluate. So this is going to require us to do just a little bit different. Look at what we know. We know f of x is equal to 32. We have an f of x in the function. So this 32 replaces the f of x. So I have the whole thing. 32 equals 3/4 x minus 4. Okay? That 32 replaces the whole entire function. That function name there. Now to solve this, I'm going to add 4 to both sides. So I have 36 is equal to 3/4 x. And remember, if we had a fraction wrapped up with that variable, we multiply by the reciprocal to get rid of it. So I'm going to multiply both sides by 4/3. Those 4s, those 3s will cancel. I get x. And over here, 3 will divide into 36 12 times. 4 times 12 is 48. So what is my value of x when the whole function equaled 32? It was 48. So what I'm doing on number 5, I'm solving for the independent variable here. I already knew what the whole entire function equaled. M of p equals negative 54. So that negative 54 has to replace the m of p. So I have negative 54 is equal to 3 times 2p minus 8. And then go through and solve this. So negative 54 is equal to, use my distributive property here, 6p minus 24. I'm going to add my 24 to both sides, and then I get negative 30 is equal to 6p. I'm going to divide both sides by 6, and I get negative 5 is equal to p. So notice the directions were different on these two.